we're now looking at our third target of our little review unit. And we're going to look at eigenfactor trinomials with a leading coefficient. Let's scroll this down so we can read it. Other than 1, and differences of squares. So yesterday, if you notice, everything, all the trinomials that we factored didn't really have a number in front of the x squared. It was just x squared, okay? So really it had a coefficient of 1 in front of that x squared. Now we're going to look at what happens when we have something that's not 1. So the first thing that might happen is that it has a common factor that you can take away. So a greatest common factor is a factor that divides evenly into every term. This idea is going to come, this idea of a common factor is going to be a big part of our Unit 8, okay? So we want to focus on, I'm sorry, I'm always making these during bells now. So we really want to make sure we know what that greatest common factor is, okay? So I'm going to determine the greatest common factor of each set of expressions. Well, if you think about 5 times x, right, 5 times x, 5x is really 5, right, times x, and 20 is really 5 times 4. So these both have a 5 in them, so that's my greatest common factor. Okay. Same thing here. This 8x is 8, nope, I'm going to break it down even more. 2 times 4 times x. I could break it down to that 4 into 2 times 2, but I see that this has a 4. So some of it is breaking it down, and then some of it is like logically and like just kind of starting to see what factors are going to be the same. Okay. And this negative 4x squared, we never really pull out a negative. Well, I'm not going to say that. But negatives are weird. If one's negative, one's positive, right? This is really negative 1 times 4 times x, right? Because that x squared means there's 2 x's. But what do they have in common? Well, they both have a 4, and they both have an x. So my greatest common factor is 4x. All right, part C. 16x squared y is 4 times x times y. No. Again, this is me. I'm going to change this because these all have a 4 in them, but if I change this to 8 times 2, then I can change this to 8 times 5 times x times y. And I can have this be at 8 times x times y times y. So I started by breaking up this one into 4s, because I could see I could divide these by 4s. And then I saw there was a bigger number that goes into all 3 of those. And that's that word greatest. So while 4 is a common factor, it's not the greatest common factor. Okay. So what do they have in common? Well, they all have an 8. They all have an x. And they all have a y. And that is it. All right, looking at part D, Same idea. This 6m squared is negative 1 times 6 times m. And then this negative 30m cubed is negative 1 times 6 times 5 times 1, 2, 3 m's. So they have the 6 in common, and then an m in common, and another m in common. So 6mn, which is the same as 6m squared. Okay. All right, so now we're going to factor our expressions by first taking out our greatest common factor. So looking at our first one, 3x squared minus 24x plus 12. Well, this is 3 times x times x. This is 3 times 8 times x. And this is 3 times 4. Hey, look. They all have a 3, and these aren't going to be able to take anything else out of all 3 of them. Okay? So what we do is we divide each of our terms by 3, and we pull that 3 to the outside. 3x squared divided by 3. Well, you can think about what's left. X squared minus 8x plus 4. This doesn't work. Huh. I think I pulled this from a worksheet. Hold on. Is not going to factor. I won't really give any problems like this to you, but we'll just say, good, that's done. If I think about my multiples of 4, right, then we just go into what adds to negative 8, right? Now we're doing exactly what we did yesterday. And multiplies to 4. And there's not anything. 1 and 4 and 2 and 2, none of that is going to multiply and add to these numbers. So then technically we're done, and we call this a prime factor. It doesn't break down anymore, okay? I probably won't give any to you like that, that don't factor, but this one didn't. All right, looking at our next one. Okay. Now we should be able to start seeing some greatest common factors a little faster. So if I look here, right, I know I can take a 5 out of both of them. So again, I'm going to move that 5 out to the front, and I have x squared minus 4. Okay? After yesterday, we should recognize this x squared minus 4 is a difference of squares. So my 5 is still on the outside, and then I have x plus 2, x minus 2. So we have completely broken that down, right? So taking on this greatest common factor allows us to have these perfect squares, where before 5 and 20 are not perfect squares. All right, we're going to make a quick change. I think it's a typo. Change this to a plus really quick. So we have 2x squared plus 14x plus 24. Okay? We should recognize that all of these can be divided by 2. So now we have 2 times x squared plus 7x plus 12. Right, this here is what I'm adding to. This here is what I'm multiplying to. Okay, so looking for my two numbers, what multiplies to 12 and adds to 7? 3 and 4. 3 plus 4 is 7. 3 times 4 is 12. All right, so same idea there. And then, so we have 2, right, that just comes down. And then we have x plus 3, x plus 4. All right, looking at part D, again, same idea. Both of these can be divided by 7. So I have 7 times x squared minus 1, which is the same as x plus 1, x minus 1. All right, coming from our square roots again here. All right, square root of x squared is x, square root of 1 is just 1. All right, looking at E, now we have some crazy variable things, right? But if we think about our greatest common factor, these crazy variable things become much easier. So this is really 2 times A times B. This one is 2 times 5 times A times B. And that one is 2 times 4 times B. So if I look what they all have in common, they all have a 2, and they all have a B. This has an A and this has an A, but this doesn't have an A, so I can't circle the A. Unless I can circle it in all 3 things, right, it's not part of my common factors. So I'm going to divide all 3 of these by 2B. Again, if you're struggling with what it's going to divide to, right, we've already actually written it up on top. If I take out the 2 and the B, I'm left with the 2 A's, which is just A squared. Should we put the 2B on the outside? Here I have minus 5A, and then plus 4. Now again, we have just a nice, easy factoring here. We are going to add to negative 5. And we are going to multiply to positive 4. Well, 1 and 4 get me close, right? But that's positive 5. So I have to change both of those to negatives. Negative 1 and negative 4 get me to negative 5. So we have 2B. Our variable here is A, so A minus 1, A minus 4. Same idea for part F, right? This is 2 times 5 x's. Right, that's what x to the 5th means. And 32 is 2 times 16 times 3 x's. So they have in common a 2. I can circle an x. I can circle an x. I can circle an x. I can't circle another x here because there's no x for me to circle here. Okay? So that's 2. I have 3 x's that I circled, right? So that's 2x to the 3rd. What do I have left? X squared on this side minus 16 on this side. This is just difference of squares now. Square root. That's x plus 4, x minus 4. All right, let's look at our next page. These ones are harder because if I look for a GCF for 2x squared minus 11x minus 5, minus 11x plus 5, there isn't one. This is just divided by 2, and I can't divide 11 or 5 by 2. It's not possible. So what we're going to do is we're going to use our divide and slide method. Okay, so I guess it's multiply, divide, and slide. So I'm going to go into my x, right? Still the same kind of idea. I'm still going to add to this number. So we're adding to negative 11. What I put down here is slightly different. What I do is I take this times this. Well, 2 times 5 is 10. And that's what I'm multiplying to. So it's one little extra step than what we've done before. Technically it's not, because we just used 1 there, and that's why we didn't have to worry about it. But now that it's not 1, we do have to worry about it. Okay. Now, same thing. I'm going to check for my 2 numbers. So I have, I think, -1 and -10 work there. Then, since I multiplied by A, I have to divide by A. This is where the divide and slide comes in. So I'm going to divide both of these by whatever A is. This doesn't simplify, this does. Okay. Now this is where the slide is going to come from. If you're left with a fraction, whatever number is on bottom, it just slides out into the front of the x. So for example, this -1/2, this 2 is going to slide into 2x minus 1. And then x minus 5. Okay, and that's it. So it's just it's like 2 extra steps. You have to multiply, and then you have to divide, if you have that number in front. Let's look at B. So we have 3n squared plus 2n minus 8. Again, we have what we are adding to, 2. And we have what we are multiplying to, right, with 3 times 8, which is -24. Right. Again, we got, knowing our factors, right, start seeing these things quickly. Again, there's not much to tell you how to do it other than kind of go through all of them, guess and check. So our 2 factors are 6 and -4. All right, 6 plus -4 is 2. 6 times -4 is -24. And now I'm going to divide by my first number. And this one does reduce. 6 divided by 3 is 2. -4 divided by 3 does not reduce. So we just have a regular n. This is an n1. n plus 2. This 3 is going to slide out. 3n minus 4. All right. Letter C. We are adding to -13. We are multiplying to, well, 2 times -7 is -14. So our 2 numbers are going to be -14 and +1. All right, the biggest mistake is people forget about 1 times the number. Divide by 2. This one reduces, this one does not. That's y minus 7. Slide it out. 2y plus 1. Letter D. 15x squared minus x minus 6. Okay, so we are adding to -1. Remember, there's a 1 in front of this x. And we are multiplying to 15 times -6, which I believe is -90. Right, coming from both of those. So 9 and 10. And I want the larger one to be negative since I add to a -9 and -10. And then we have to divide. So we're dividing by 15. Both of these reduce. 9/15 reduces to 3/5. -10/15 reduces to -2/3. Okay, so sometimes you'll have them both reduce. So now we're doing divide and slide. Both of them have something that are going to slide out. 5x plus 3. (3x minus 2). Okay. Real quick, we're just going to do these last two. I'll run through them. Now, I want to be careful. I still want to check for a greatest common factor if I can. If I look at E6, 2, and 4 are all divisible by 2, okay, it'll make the problem easier because you won't have to think of your big numbers, okay? So we have 3x squared minus 1x minus 2. Adding to -1. Multiplying 2. 3 times -2 is -6. And that's going to be 2 and -3, right? I'm going to divide by 3. I'm running through these quickly. This one is -1. So our 2 is still out in front. This slides, so I have 3x plus 2. And then x minus 1. Same thing here. They all also divide by 2. Alright, otherwise this would be like a really big number, so it's nice to get that a little bit smaller of a, like, what I'm trying to multiply to. Plus 19x minus. So I'm adding to 19, and I'm multiplying to -42. That is 21 and 2, -2. Okay. Again, we're going to divide by 14. Both of these reduce. This becomes 3/2. This becomes -1/7. We have 2 times, slide it out, 2x plus 3, slide it out, 7x minus 1. Sorry for the little bit longer video. I tried to do those last two a little bit quicker because it was just combining the two things we did. But we'll practice all of this tomorrow. Have a good rest of your day.